All right, the practice test for the exam. This is a pretty good representation of what will be on the final test. There's only a few questions per section, so this is about the same length the test will be. And I'll give you some more hints as we go through. So number one says find AC. All right, so AC is the entire length. If AB is 28, BC is 6, you're literally just adding them, so that means AC is 34. Okay? Now, you got to pay attention to the details. If I would have given you AC, let's say AC was 28 and BC was 6, and you were trying to find AB, then you would subtract them. So you just got to pay attention. Sometimes stuff will be labeled, sometimes it won't. You might have to fill some stuff in. So just pay attention to the details. Read directions. All right, BD, it bisects ABC. So here's BD, it is a bisector. That means this angle, ABC, this whole angle is being cut in half, which means that this angle here is going to be equal to that angle to here because it is being bisected, cut into two equal parts, which literally means this one equals that one. So we just write 5x minus 12 is equal to 3x plus 20. I'm not going to show all the baby steps. I'm going to subtract 3x and get 2x. I'm going to add 12, so I'm moving this over here. I'm going to move this over here by adding, so that gives me 32. Divide by 2, x is 16. Now again, look at the directions. It says find the value of x. I'm done. But maybe it would have said find the angle ABD. Or maybe it would have said find DBC. Or maybe it would have said find ABC or any of those above. If that was the case, you could plug 16 into either one of these and find the angle, all right? And you would have found out that this was 68, which means this was 68. And if you're trying to find the whole thing, 8 and 8 is 16, 6 is 12 is, 136. So again, it was not asking for that, but you have to be prepared to answer those questions. And it just simply means plug in 16, get the value, they're equal, and maybe double it. It wasn't asking for that, but maybe it will on the test, so always be prepared, but always read the directions to know what it's asking you to do. Find the midpoint of AB. This is the easy one. This is where you just add x plus x and divide by 2, and add y plus y and divide by 2. So in this case, 4 plus negative 8, divide by 2. Negative 2 plus 6, divide by 2. Well, 4 minus 8 is negative 4, divide by 2. 6 minus 2 is 4, divide by 2. And that gives us negative 2, comma 2. So again, when you're finding the midpoint, you're literally just adding the x's divided by 2, you're adding the y's and dividing by 2, and then working out the math. All right, numbers 4 and 5 refer to this picture over to the right. It says name 3 points that are collinear. Collinear means on the same line, together on the same line. Well, there's only 2 lines drawn. Line G only has 2 letters on it, W and Q. So it can't be that. So if we look here, point R, point Q, and point S are collinear. Now it says name the plane 2 different ways. Well, one thing I always look for is a letter with no dot. So we write plane V. That's one way to name it. Plane Q does not work. Plane T, plane S, plane R, plane W, none of those work. Plane F does not work because it's not a capital letter. That's the name of that line. All right? Another way is to pick 3 dots on the plane that are not in a line. So what are my options? I have a T, an S, a Q, and an R. The only three I cannot use are those three because they're collinear. I can use any two of them. Okay. So again, I write the word plane. I can do R, T, S. I could do RTQ. And I could do STQ. Now, I don't have to do all those, but those are my options. The only one I cannot do is RQS. Again, W doesn't help me because it's not on the plane. F doesn't help me because that's a lowercase letter, which means it's the name of the line. And V does not help me here because V is not a point. So here are my two options, plane V and then one of those three. What is the complement of 71 and what is its supplement? So remember, complement comes before supplement in the alphabet. C comes before S. 90 comes before 180. So complement has to do with 90, supplement has to do with 180. So all you do is type in your calculator 90 minus 71. So the complement is 19. 71 plus 19 is 90. The supplement is 109. 109 plus 71 is 180. You literally just subtract those numbers. And you subtract those numbers to get the two answers. But this is the key to remember. Or, hint, hint, maybe put on a cheat card to remind yourself. Okay, using the conditional. If you study for the cumulative, you will do well. It's not a guarantee, but it's most likely. Write the converse. Now, here's one of those things that I would put on the cheat card. But remember, just because converse is on the practice test, it's likely it may not be on the actual test. So on your cheat sheet, I would remind yourself what converse means, what contrapositive means, all the different terms. So that if one of the other ones is on the test, not converse, you are prepared for any of them. The converse is very easy. The converse is where you're just going to switch them. Now remember, sometimes it's awkward. If you do well on the test, then you study. That doesn't sound right. So you might have to change tense. Okay? So if you do, or maybe did well on the cumulative, then you studied. So changing the tense might make it make a little bit more sense. If you do well in the cumulative, if you did well in the cumulative, then you studied. Not for sure, but most likely. All right, what property is shown here? I would put on a cheat sheet if I had one, all of the properties. Now, do you have to waste space on a cheat sheet writing addition, subtraction, multiplication, division? I would hope not. I would hope these are kind of obvious ones. So if you look at these two, what changed between here and here? Well, obviously I added 5 to get 17. So this is the addition property. Now, technically it's the addition property of equality. I'm fine with you just writing addition. It says if x equals 7 and 7 equals y, then x equals y. What we did was we cut out the middleman, just said x equals y. That's the transitive property. This is one I would put on a cheat sheet. So in other words, I gave my friend Bob a cold. Bob gave Susie a cold. I effectively gave Susie a cold because she caught it from somebody I gave it to. That's a transitive property. I transitive moved it to this person. They moved to that person. I basically moved it to the third person. All right. Inductive reasoning. I would put on both of my cheat sheet inductive reasoning and deductive reasoning to remember which one's which. Okay? Remember, inductive is like investigate, like Sherlock Holmes. You look at clues. Okay? Deductive is like definition, like known facts. So inductive means you need to kind of prove this by testing some theories. So, product of two negative numbers. Also, I might put on my cheat sheet words like product means times, sum means addition, different means minus, okay? Some of these words threw some of you for a loop earlier in the year. Quotient means division. I would write these terms down on your cheat sheet so that you know what these mean. But just take two numbers. -5 times -3. Oh, that's 15. -1 times -2. Oh, that's 2. -3 times -3. Oh, that's 9. What do these all have in common? Well, the product of two negative numbers is positive. So I inductively tested some theories. I looked at clues like Sherlock Holmes. I looked at the clues in the crime scene, and I came up with a prediction. That's inductive reasoning. Deductive is, if I throw this apple in the air, it will fall. Why? Gravity. That's a definition. It's a known fact. Number 10, what property of equality is shown here? If AB is 12, then 12 is AB. They're just switching places. That's symmetry. The left side matches the right side. Like if you draw a line down your face, generally the left side somewhat matches the right side. B, what happened? Well, 3x plus 4 equals 10. 3x equals 6. What happened? Oh, I just subtracted 4 from both sides. So that's the subtraction property of equality. Do you have to write all that? No. Do you have to put this on a cheat card? Hopefully not. Complete the statement using the distributive property. Distributive just means multiply here and here. 3 times x is 3x. 3 times 4 is 12. The most common error in algebra, geometry in algebra 2, is writing 3x plus 4. Forgetting to distribute to both items. All right, this is the easy proof. This is just math. Okay, so we write down 4 parentheses 2x minus 3 equals 44. And we just write given. The properties here are really easy. They're the ones you already know. So I'm actually going to do this two ways because there's two ways to do this. Since 4 actually goes into 44, I can save myself some work and have smaller numbers by starting off by dividing by 4. What's that property? Oh, division. Not too challenging. When I divide, I'm left with 2x minus 3 equals 11. What did I do? I simplified. Now I'm back to algebra 1. I add 3 to both sides. What did I say? I add 3. So I write addition right here because I added 3. Nothing too challenging. When I do that, I end up with 2x equals 14. What did I do? I simplified. To get x alone, I divide by 2. What did I do? Oh, I divided. That's that division property again. X equals 7. I simplified. Now, some of you might have started off by not thinking about dividing. Some of you might have gone ahead and done 4 times 2 is 8x minus 12 equals 44. You can write this down or you can just listen. It's up to you. What property did I use? Well, you could say multiplication or distribution, either one, because that's what you did. You multiplied, you distributed. And then you'd add 12. Notice here I added 3. It's still the addition property. Then I would simplify it. I get 8x equals 56. Divide by 8. That's the division property. And then I'd be right back to x equals 7. So it's the same answer. It's just two different ways of getting there. Either one's right. They're about the same amount of time. It just depends on which you want to do. This one, you just got bigger numbers, but you have calculators. So is it a big deal? Not really. But it's two different ways of doing the same problem. Now, if this number here was 45 or 43 or 41, I could not have started off by dividing. I would have to distribute. I'd probably end up getting a decimal answer, and that's okay. But if it is a factor, it is a possibility. It's kind of a shortcut. It doesn't really matter, though. All right, name a line parallel to NM. This is where using colored pencils on test might help. Here's NM. What's parallel to NM? Well, I can move it magically here. Those are all parallel. But I'm going to mark them. KL, RS, QP. Obviously on the test, you do not have to name all of them. But for studying purposes, I am going to name all of them. But looking ahead that we're going to be doing skew, this is where it kind of helps to mark all of them. I'm going to take a different color. Remember, skew, which you might want to put the definition of on your cheat card, means not parallel and not touching. So I'm going to do all the lines touching NM. That touches NM, that touches NM, that touches NM, that touches NM. Again, if you do this on the test with different colors, it's kind of nice. So what do I do now? I find all the lines that are not in red or blue. I could circle them or I can mark them in a different color. There's one, there's one, there's one, and there's one. So, skew lines are PS, QR, KR, and SL. Those are all skewed. Now again, it says name a skew line. But for studying purposes, I would write them all down. But that's up to you. All right, name all angle pairs that are congruent. Notice parallel lines. Okay, so some obvious ones, even without parallel lines. Vertical angles are going to be congruent. So 1 and 4 are going to be congruent to each other. And so are 5 and 8, 2 and 3, 6 and 7. But knowing that we have parallel lines, remember, we also have corresponding angles. So 1 and 5 are congruent. And 5 and 8 are congruent. So actually, 1, 4, 5, and 8, hint, hint, all the obtuse angles are all congruent to each other. 1, 4, 5, and 8. All 4 of those angles are congruent. Therefore, all the acute angles, 2 and 3, and 6 and 7, all the acute angles, they are also all congruent to each other. So 1, 4, 5, and 8 are all equal, and 2, 3, 6, and 7 are all equal. Now, again, think about this when you're going into the test. We've talked about this numerous times. Acute angles and obtuse angles are never going to be equal to each other. All right, 16. Find the value of x that makes the lines parallel. Well, we're talking about alternate exterior angles. Alternate means one's on the top, one's on the bottom. Exterior, they're outside these two lines. So for those two lines to be parallel, 8x has to be equal to 4x plus 24. If I subtract 4x from both sides, I get 4x equals 24. If I divide, x equals 6. That is the value that makes them parallel. Cool thing about math is I can plug this in and get 48 degrees. It's not part of the problem, but it helps me prove I'm right. And if I plug it in here, 6 times 4 is 24, plus 24, guess what? Is 48. I can check my answer to make sure I did it right and get the right answer. Let's say I did something wrong, and here's why you check your work. Let's say, and I've seen some of you do this, you did the math in your head, you didn't check it on the calculator, and you got x is 7. All right, plug it in. 7 times 8 is 56. 7 times 4 is 28. 28 plus 24 is 52. Oh, wait, those numbers don't match. Probably means 7 isn't right. Maybe I go back to my calculator and check. Oh, shoot. 24 divided by 4 is 6, not 7. We all do it. I've done it. It's a simple mistake. But the beauty is, if you don't rush and you take the time to check your answer, you might know if you're right or wrong before you go to the next problem. These are ways you help yourself. 17. What is the slope of the line parallel to y equals 3 half x plus 1? Well, first off, remember, this is y equals mx plus b. M is the slope. Parallel means the same. Perpendicular means opposite reciprocal. So the parallel slope is going to be the same, 3 halves. The perpendicular slope is going to be opposite and reciprocal, negative 2 over 3. Find the values of x and y that would make the lines parallel. Well, first off, these two are vertical angles. Whether they're parallel lines or not, those are going to be equal to each other. Oh my God, I got a decimal answer. I must be wrong. No, decimals are our friends. It's okay. Y is 29.5. Okay? Now, for parallel lines, though, we have alternate exterior angles. But the problem is, don't write this down, this does not help us because one's y and one's x. But we also have corresponding angles. So we can say 3x minus 4 equals 59. Now we just do the algebra. Add 4 to both sides, and we get 63. Divide by 3, x is 21. Again, here's the beauty of math. 3 times 61 is 63, minus 4 is 59. Cool, I did the math right. Vectors. Here is a vector. You know it's a vector because it has those little V's on the side, sideway V's. What does it mean? This means right 4 and down 7. That's it. It's that simple. It means from whatever point you're at, move right 4 and down 7. So if you're translating a shape or a point or a segment, that's how you would move. Last one on this page. plot point A at negative 4, 3. So go left 4 and up 3. And that's going to be 1, 2, 3, 4. 1, 2, 3. There it is. There's negative 4, 3. Reflect it over the y-axis. Where's the y-axis? It's this one. Okay? Which means we're just folding it over here. All you literally have to do is count from here to the axis and then count over. So it's 1, 2, 3, 4 spaces. So then you're going to go 1, 2, 3, 4 spaces right there. So it goes from negative 4, 3 to positive 4, 3. That is the new point folded over the y-axis. Now, it didn't do it, but if it was folding it over the x-axis, you would go down there. And that would be at negative 4, negative 3. Again, not what I was asking, but just for studying purposes, getting ready for the test, that would be folding over the x-axis. All right, plot A at 3, 5. So 3, 5. There's A. Rotate it 90 degrees counterclockwise. Now remember, that means it's going to be rotating one quadrant over. So when we do a 90-degree change, we've had these on our cards earlier in the year, that means y comes to the front and becomes opposite, and x moves to the back. So y moves to the front and becomes opposite, and x moves to the back. So negative 5, 1, 2, 3, 4, 5, 1, 2, 3 would be right there, and that would be A prime. A with an accent mark or an apostrophe. Again, all these changes, we'll do more of them in this review, would be good things to put on your cheat sheet. So that's a 90-degree one right there. We'll get to the other ones later. All right, draw all the lines of symmetry you can through this image. All right, very easy. First off, you do all the dot to dot, corner to corners. Should be easier than this, but it's always a little bit off. So there you go. I'm just going to freehand it. So corner to corner on all these. And middle to middle. So split all these straight down the middle of each side. Middle of each side to middle of each side. Middle of each side to middle of each side. We refer to those terms as medians. There you go. Looks like a tarantula. But that's all the lines of symmetry, because you could fold it side to side and corner to corner. This one, not so many. You basically can fold it top to bottom, and that's it. There's no other lines of symmetry. It's just that one. Scale factors. If you're reducing something, you're going to multiply between 0 and 1. Not including 0, not including 1. Okay? In other words, in algebra, it would look like this. Not less than or equal. I didn't mean to do that. Because it does not include 1 and 0. Because if you multiply something by 0, it goes bye-bye. If you multiply by 1, it's going to be the same thing. So reduction is a fraction in between those two. And enlargements are going to be greater than 1. Usually numbers like 2, 3, 4, 5, but it could be 1.5, 2.5, 1 3/4, but we'll usually keep it simple. But it's a number bigger than 1. Because if you multiply bigger than 1, it gets bigger. All right, last one on this page. Can't get that watermark out of the way. So, first off, we're going to put 4, 0 on our, and 8, 0, and 6, negative 3. And we're going to connect them as straight as possible, and we're going to put A, B, and C. Now, we're going to do two transformations. Okay, this is a composition. We're going to first translate it. This means left 7 and up 4. Now, there's two ways to do this. Mathematically, you could subtract 7 from all these x values and add 4 to all the values. Or you could literally just count. 1, 2, 3, 4, 5, 6, 7. Oh, sorry. That's where I'm starting. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and then up 4. 1, 2, 3, 4. And then B, 1, 2, 3, 4, 5, 6, 7, and up 4. And then this one, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. And there are my new points. A prime, B prime, and C prime. And we're supposed to write them over here. So A prime is at -3, 4. B prime is at 1, 4. And C prime is at -2, 1. Okay. Now it says multiply everything by 2. So we're literally going to just multiply all these numbers. So -6 and 8. 2 and 8. -4 and 2. And we're going to graph them. Let's do a different color. So -6, 8 up here. 2, 8 up here. -4, 2 right there. Connect the dots best as possible. That's A double prime. That's B double prime. And that's C double prime. Moving on. Getting there. Given the congruent statement, SUM equals FAL, again, I like to write them underneath each other or over each other, whatever, so you can completely see what lines up with what. Name all the corresponding sides and angles. All right. Angle S is congruent to angle F. Angle U is congruent to angle A. And angle M is congruent to angle L. Then SU, FA, SU, FA. UM, AL. UM, AL. And SM, FL. SM, FL. Makes it so much easier that way. Okay, I think I miscounted. Oh, there's my problem. I put the point here at 5, -3. I made a boo-boo. I put it at 5, -3 instead of 6, -3. So that should have looked like that. Therefore, when I move 7, this should have been up here at -1. So that should look like that. So this should be -1. And when I multiply by 2, that should be -2. So I got to clean this up a little bit. Come on. So that should be a -2, +2. -2, +2 would be right here. and look like that. So I knew something looked wrong, but I didn't catch it. And that's because I plotted this point right here incorrectly, which is again why we all make mistakes. Double check your work. All right, back to 26. Now, a lot of mistakes were made on this test. Please listen carefully for this. A lot of you are like, oh, there's two lines equal, so the two angles are equal, so that makes that 64. No, it does not. Draw your lines. That angle equals that angle. So these are the two angles that are equal to each other. Those two are 64. So 64 times 2 is 128. All right? Which means right here we've used up 128 degrees. So we have to subtract 128 from 64 and get 52. So this right here is 52 degrees. Again, don't be lazy about it. Yes, you got the idea, oh, two sides are equal, two angles are equal, but that doesn't mean the angle I'm looking for is that angle. You've got to draw the lines and make sure you label them correctly. So the answer is 52 degrees. Now, if the x was down here, then yes, it would have been simply 64 degrees, a lot less work. But you've got to pay attention to what is being asked. All right, 27. How would you prove these congruent? Well, right now you can't. As soon as we see a line like this, we should go through and mark it. Anytime we see a reflexive line, mark it. Now, that lines up with that. If that's 90, that's 90. Now you see 90, you might think, oh, HL. Not HL, because we don't have the hypotenuse marked. So we can't use that HL. But we do have an angle here and an angle here, and a side here and a side here. So we can do SAS. Now, again, if we would have had these marked congruent, then we could have done HL because of the right angle. All right. Whenever we see vertical angles, we should automatically mark them. And then we have angle, angle, side, angle, angle, side. We can prove it by AAS. Here we have a reflexive line again. So we have angle, side, angle, angle, side, angle. That is our justification, angle, side, angle. $28. If one angle, acute angle of a right triangle is 52. So immediately draw a right triangle and mark it 90. It doesn't matter which one you put, 52 right there. We're trying to find this one right here. What's the other angle? There's two ways to do this. You can add these together, 90 plus 52, and get 142. And then subtract that from 180. Sorry, 152. No, 142 is right. And get 38. That's one way to do it. The quicker way is, if it's 90 degrees, those two have to be 90 degrees. So I could have just done 90 minus 52 and gotten 38. Either way is right. This way is a little quicker, but it doesn't matter. They both work. 29. If R is the midpoint of AS, so here's R, it's the midpoint of AS, that means those two are equal to each other. It says CR bisects ARS. Well, ARS, again, is this line right here. That's a 180 degree straight line. So if that's bisecting it, then we know those two are equal, or they're both 90. It doesn't matter. We also know the reflexive line should be marked. Therefore, we have SAS, SAS, and we say SAS. Again, no HL because we do not have the hypotenuse marked. So we can't mark that. And last but not least, oh, it's a proof. Notice though, little gift to you, it's a fill in the blank proof, like the one will be on the test. Now, the other proof earlier was not fill in the blank, but that was just solving algebra. This one, fill in the blank. So let's see what we got here. PR bisects QPS and QRS. So we have two choices. We can fill that in right now. PR bisects angle QPS and angle QRS. Give it. We can also mark it on here, either one first. So PR bisects QPS. Well, where's QPS? QPS is right here. If it's bisecting it, that means this is equal to that. So we mark it. It also bisects QRS. Where's QRS? Right here, which means this angle is equal to that angle. We mark them. Now we go down to our proof. Notice, definition of angle bisector. Well, there's going to be two of them. So we skip ahead to 3. Here's QPR and SPR. That's those two. Which means number 2 is probably going to be the other two. Angle QRP is congruent to angle SRP. Definition of angle bisector, definition of angle bisector. So, how do we know which one to put here? Because we looked here. Again, if this wasn't fill in the blank, you could have done either one first, but since one of them was done, the other one goes in the other place. Okay? We see reflexive property. Well, what did we mark reflexive? PR. PR is congruent to itself. And we mark that. Actually, we could have used one line because we haven't marked any other lines yet. Hey, we're done. Whoops. Triangle equals triangle. What property? Let's look. Angle, side angle, angle, side angle, angle, side angle. We see CP, CTC. Where did we get that from? Right there. We can call any part equal to any other part once we have the triangles proven. That's all. Solve for x and then find TU. Okay, notice it's saying find TU, which is just going to be this part. It could have also asked for TR, so pay attention to directions. So what do we have going on here? We have that whole rule that if we have a bisector, okay, then any point drawn perpendicular will be equal. So we know these two are going to be equal. So we just do the math. 2x plus 24 equals 5x minus 30. Now, I like to keep my variables positive when possible. So I'm going to move this over here by subtraction and get 3x. Which means I'm going to move this over here by addition and get 54. Now again, some of you are not good at doing this mentally in your head and probably should write plus 30 under here and plus 30 under here and minus 2x and minus 2x. If that's you and you know you make those mistakes and accidentally get, a 7x or negative 14, if you know you make those mistakes, then do the baby steps in between and show your math. But I'm going to divide 3 now and get x equals 18. That was only one of my two answers. It said plug it in and find TU. Again, pay attention to what it's asking for. TU, plug it in, 2 times 18 plus 24. 2 times 18 is 36, which means TU is 60. But again, remember, it might have asked you for TR, which means plug it in, double it, 120. Pay attention to what it's asking for. All right, same kind of idea here. Those are literally equal to each other. It's the same idea as the previous one where I extended the lines. So 3x plus 1 equals 5x minus 1. Again, I'm going to subtract 3x. I'll show the work this time. I'm also going to move this over here, so I'm going to add 1 and add 1. Those cancel, those cancel. I end up with 2x equals 2. Divide by 2, x equals 1. But remember, it said find x and BD. Well, BD is right here. So if I plug in 1 right there, 3 times 1, 3, plus 1, 4. BD equals 4. Last page. All right. It says CG is 30. CG, if this is 30, is the big piece. The small piece is 15. But it's not asking for, well, it is asking for the small piece. It says find GF. GF is 15. It also asks for CF, which is the whole thing. 30 plus 15 is 45. So remember, when you have these medians, they form the centroid right here. It's got a very simple ratio of 2 to 1. The small piece is 1/3 of the whole thing. So if they would have given us CF, if they would have said CF is 45, you would have divided by 3 and gotten 15. And then you double it to get 30. But if they gave us the big piece, you cut it in half to get 15. If they gave us 15, you would have doubled it to get 30. So you can go any direction. You just got to be able to play with those numbers. Again, good thing to have on the cheat sheet. All those different ratios. All right, this one. Now, this one drives me crazy, especially when it does that. We talked about this numerous times. We've talked about it all year, the common sense rule. Does that, don't answer this question, but does that look the same as this? No, it doesn't. It does not look the same. Yet many of you on the test on this chapter told me x was 28. Like half the class. That's ridiculous. This is half of that. You can literally see it smaller. So, whoops, x is 14. It's half of it. Last but not least, graph the triangle. Let's see if I can do this right this time. 3, -6. 3, -6. It's down here. I did it right. 3, -6. -6, -3. -6, -3. -6, oh, I did that right. And 0, 3. 0, 3. Whew, I did it right. Again, you should be using a straight edge when you're doing your test, a ruler, your ID, your driver's license, use a straight edge. Now, it says find the centroid. This is easy. You literally just add the x's. 3 plus 0 plus -6. Now, here's the crazy thing. On this test, many of you did that and divided by 2. It's the same concept as the midpoint when you add 2 things and divide by 2, but use a little common sense. You're adding 3 numbers this time, so we divide by 3. Then we add the y's. -6 plus 3 plus -3. And we divide again by 3. So over here, 3 minus 6 is negative 3 divided by 3. This one's easy. Those cancel. 3 minus 3 is 0. Negative 6 divided by 3. Negative 3 divided by 3 is negative 1. Negative 6 divided by 3 is negative 2. That's the centroid. At negative 1, negative 2. And if we went through and tried to draw the medians, yep, that's the centroid right there.